Hi everyone, and welcome to RootCon, and thank you for spending the time to hear what I have got to say, and I hope you find it useful and that you learned some new things. I'm Yehuda Galb, a security researcher at Checkmarx, and in this presentation, I will be speaking about software supply chain security from an attacker's perspective. Supply chain security has been a topic of great discussion over the past few years, and its spotlight only continues to grow. But don't take my word for it. Major analysts such as Gartner have been warning of the exponential increases in software supply chain attacks over the last few years. Governments have been taking note of this problem as well. The United States government had even released an executive order on this issue of improving the software supply chain security. But what exactly is software supply chain, and how has it become such an issue? When comparing the software supply chain to the traditional supply chain, the flow is quite similar. When producing a product, materials are gathered from different suppliers from different locations, which are then assembled together under one roof and then shipped to the customer. When developing software, the process is similar in a way, where it starts with the developers writing code using some source control, for example GitHub. During the development process, the developers will combine a whole bunch of third-party code into their source code, and in the end, have a finished product that will be shared with the consumer. This diagram is actually part of a framework called SALSA. SALSA has been put together and pushed by major corporations, including Google, the Linux Foundation, Intel, and more. I should note that these companies are not security vendors. However, they have been putting many resources into this project because of how much they rely on software, especially open source, and understand the importance of securing it. Going back to the supply chain flow, each letter represents another threat vector from which an attacker can compromise the entire supply chain. Fortunately, most of the threat vectors in the supply chain are fully within the control of the organization, and CISOs can implement various controls to reduce the attack surface. However, there is one piece in the supply chain that is outside the control of the organization, and that is dependencies. The third-party open source software that is integrated into the workflow. A CISO can enforce, for example, two-factor authentication on all developers within the organization. However, they can't, for example, enforce two-factor authentication on open source developers or harden their workstations. They can ask, but they can't enforce it. Okay, so open source software is a concern, but how big of a concern? How many are actually using open source software? Well, everyone is using it. And the follow-up question is, how much are they using it? What percentage of the final code contains open source? As a matter of fact, quite a lot. So it's safe to say that, yeah, open source software is of great concern. And if it's such an issue, why is it still attractive? Why is it so attractive? Why is everyone using it? For one thing, it helps developers deliver fast. There's a continuous rush to release software as soon as possible, and if someone out there has already written code that performs the needed functionality, then rather than reinvent the wheel, a developer could simply use that code in his own project. Okay, so you might be thinking, why doesn't an organization just scan that third-party software to ensure it is safe? This brings us to dependencies and the dependencies of dependencies. When a developer desires a certain software package from some open source project, that package is normally dependent on some other open source package that grants it certain functionality. And if only this was only a one-to-one ratio. In reality, it is a one-to-many ratio. Let me show you an example. Let's assume you want to add a software package named CNCJS to your project. During the installation of this package, behind the scenes, you're adding an additional 811 packages from 611 different contributors. Now, who has the time to check every single one of these packages and maintainers? Open source has become literally a jungle. But unlike other jungles in this world, this one seems to be increasing at a fast pace with no signs of slowing down. On NPM alone, there are over 500,000 packages releases every month. So should we be using open source or should we avoid it? Well, to be honest, this is no longer a dilemma. We're going to continue using open source. That ship has already sailed. The question that is more relevant is, how do we choose the right open source software? One of the reasons open source is so attractive is because of the misleading trust it gives us. If open source is open for everyone to look at, if there is some problem, surely someone will notice and raise a flag. There are also various scoring mechanisms that display a project's popularity and user satisfaction. These scoring mechanisms allow others to determine if the project they are interested in is trustworthy. This is all good until it's not. Until good packages become bad packages. Meet Faisal. He's a good guy, lives in Indonesia. Faisal maintains a project called UA Parser. UA Parser is an extremely popular software package that achieves over 10 million weekly downloads. UA Parser is also very well maintained. Faisal has been maintaining this project for over a decade. Among the millions who use this package are giant corporations, including Facebook. Even if you think you aren't using this package, you probably are through some dependency. So now I ask you, would you use it? Why wouldn't you? Then came October 5th, 2021. We noticed in a Russian underground forum someone bragging about getting a hold of credentials to a very popular developer's account, which has millions of weekly downloads and has no two-factor authentication, and they were selling the credentials at a starting price, wait for it, $10,000. Apparently, someone was willing to pay, because a couple of weeks later, we saw this. Faisal shared with everyone that someone had hijacked his account and was using it to spread malicious versions of his UA Parser package. The attacker had published 3 versions of the UA Parser package with the intention of infecting as many users as possible with malware intended to steal credentials and turn the affected machine into a crypto miner. Was this incident a one-time case? Nope. Just 2 weeks later, 2 additional open source packages had been compromised due to an attacker taking over the account of the legitimate developer. The 2 infected packages were Koa and RC, which were also well maintained and highly popular, with 22 million weekly downloads combined. When taking a closer look, we found an interesting commonality between the account takeover cases. All infected packages contained the same malicious code. After further research, it became clear that the same attacker was behind all the attacks. If only this was an isolated case. The reality is, we are seeing more and more attacks on good packages. Meet Brandon, an interesting fellow. During Brandon's free time, he maintains dozens of open source packages. He's truly trying to make a positive impact on the world. One of Brandon's more popular packages, NodeIPC, he has been maintaining for over 8 years and has a weekly download rate of over 1 million. His package is so popular that even if you aren't directly using it, you're most likely using it through some dependency. But something happened in March of 2022. Brandon added some new functionality to his NodeIPC package. The additional code was a bit cryptic. But once deobfuscated, we noticed something quite interesting. The first part of the code is checking the location from which the machine is running the code. It uses a website called IP-geolocation. In my case, it would show that I am in Israel. For someone else, it could be some other location, such as the United States, or Germany, or South Africa, and so on. Next, the code checks if the result given by the IP geolocation indicates that the code is running in Russia or in Belarus. And if so, and you don't need to be a developer to understand what the next bit of code is, delete, 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 delete. Brandon effectively turned his software into a bomb, which blows up on anyone located in the wrong part of the world. Not only that, but he replaced the deleted data with a heart emoji. Why did he do that? What happened all of a sudden that got Brandon all worked up about Russia and Belarus? It seems that he decided to take sides in the Russia-Ukraine war. So the question comes up, was this another case of an account takeover attack? No, it was Brandon himself, and he made sure everyone knew about it. He wrote, "You download my software? for free, so I am allowed to wipe your computer. This is all public, documented, licensed, and open source. He even gave his attack a name, Protestware. Not everyone seemed to agree with what Brandon did, and weren't shy in expressing their thoughts. Among them were comments like, "Brandon, that's an abuse of power," and "Thank you for teaching me not to take code from strangers." If you were not one of those residing in Russia or in Belarus, would you still use this package? What about his other packages? Would you still use them, even if they were clean of malicious code and vulnerabilities? Would you even know if you were using any of these packages? With great power comes great responsibility. Whose responsibility? Is it the open source contributor? We probably shouldn't automatically say that it is the contributor's responsibility. But these are not the only types of attacks that we are seeing out there. So what we have seen in these cases I just demonstrated were contributors who worked hard to gain their good reputation, yet have very easily lost it. So we have seen now that if you have assumed that you can keep safe by using only packages that are popular, well maintained, and with contributors that have a very good reputation, these cases have shown that it is not the case. We have also been seeing dedicated, organized, and professional threat actor groups entering this field, which are rapidly improving their attack techniques and impact size. One example is of a threat actor we caught earlier this year called Red Lily, who had been able to publish over 1,500 malicious packages within a month. This is a lot of packages, and was one of the largest attacks on the open source software at the time. Red Lily had been able to accomplish this by building themselves an entire infrastructure intended to create packages at scale through automation. Not only that, but their system was able to create a unique account per package they released. Now, when creating a new user account on NPM, they require two-factor authentication validation to activate the new user. But Red Lily's infrastructure was able to defeat this challenge. They also used many disposable domains to make it tough to block them. And for a while, we played a game of cat and mouse with them. They would continuously upload new packages and try to improve their techniques, and we would continuously catch them and take them down. After a while, they started getting frustrated with us and started communicating through their package names, which was kind of amusing, I must say. We wanted to share information of this campaign with the research community, and so we launched a site called redlily.info, where you can browse all the packages that Red Lily had published and the details surrounding them. You can also find if any of the packages are still available or had already been taken down from the package manager. Among the details of each package are also some of the behaviors of the package. For example, in this one, you would see that it uses obfuscated code and the endpoint to which data is exfiltrated to. If the package is still available on NPM, you could follow the link to see the live package on the site. So you're welcome to check it out. Again, it's redlily.info. And here, by the way, is one of the packages I mentioned earlier, the FU scanner. Just a short while after Red Lily, an attack group called CuteBoy showed that you don't need to build a whole complex infrastructure to accomplish something similar to what Red Lily had done. CuteBoy was able to publish over 1,000 packages from over 1,000 unique users. But unlike Red Lily, CuteBoy had found an already made service called MailTM to do the heavy lifting of creating emails for them, allowing them to automate the registration process of sites that require email confirmation. Similarly to Red Lily, we published a website documenting the activities of CuteBoy, which is available at cuteboy.info. So again, I encourage you to check out the sites. What I would like you to remember from these two examples I just spoke about is that we are dealing with determined attackers who will not rest until they accomplish their goals. They will continue to improve their techniques and will continue to try until they succeed. If you remember earlier when we talked about the good reputation that is hard won, this begs the question, is it really hard won? As you will see shortly, there are some shortcuts you can take here. For instance, take a look at these two images. Can you spot any differences between them? Did you notice the name? One is called Pampy and the other PAMPI.io. Other than the name and the release date, everything else is identical. Same description, same project statistics. The intent of the attacker here was to trick developers who misspell the name of the legitimate package. A developer who makes a typo and lands on the malicious package instead won't realize they made a mistake. But I bet you're thinking now, wouldn't the developer notice the mistake later after downloading the package? Unfortunately, the answer is no, because both packages contain the exact same code. PAMPI.io was a perfect clone to PAMPI, except for one small difference. PAMPI.io had an additional dependency. This dependency contained an obfuscated link, which when deobfuscated, exposed that it was a link to which machine environment variables were supposed to be sent to. So it seems that the whole purpose of the malicious package was to steal environment variables. And as you've probably understood by now, PAMPI.io is the malicious package. Now I'd like you to focus on the statistics. They are both the same. From a developer's point of view, when they land on the malicious package, they will think it is a very popular one. And it's probably okay. How is it possible that they both contain the exact same statistics? The answer is simple. Much of the ecosystem was not built for security. It was built for developers by developers. So they are not screening any of the information uploaded as part of the package's metadata. The attack used in this case is a combination of typo squatting with starjacking. Typo squatting is where the names are so similar that anyone who accidentally performs a typo will land on the malicious package. And starjacking is where the statistics of the legitimate package are mirrored over to the malicious package to trick others into thinking it is a popular package. This type of attack is very attractive to attackers since it allows them to easily compromise many machines within a relatively short period of time. In this specific example I brought up of PAMPI and PAMPI.io, PAMPI.io had been downloaded over 70,000 times by developers before being taken down. So you might be wondering, is this really that easy? And the answer is, unfortunately, yes, it is really that easy. Let me show you. So what you see here is a demo of an attack performed through a lab that we created for testing purposes, which we call Package Lab. So now we are going to, from an attacker's point of view, publish a malicious package to the popular PyPI package manager platform. The first thing you will need is some kind of identity, which we will create right now. You don't need any personal details when creating an account, such as an ID or credit card details or anything like that. An email of any kind is good enough. Then you choose for yourself a username and password. An account is necessary to publish the packages. Next, you need to provide details of your package. You can choose any name you'd like for your package. But in this example, I chose Supply Chain Demo as the name of the package. Now, if you were trying to perform a typo squatting attack, you would want the name to be similar to some other popular package. Next, I need to give the package a version number. A quick tip here is never give the package version 1. No developer will download a package that is version 1. So here we will choose 1.2.3 as a version number. Now is where the interesting part happens. You can think of what I am doing here as similar to uploading an application to an application store, similar to adding an Android or Apple app to the App Store. Here, PyPI is like the App Store of the package I am uploading. One of the things PyPI asks is, what organization do I belong to? I don't belong to any organization, but what I can do is browse through GitHub and choose any trending project I find there. For example, here I decided to go with the Economist ebooks. I copy the project's link and paste it into my package details. As soon as I do that, did you realize what just happened? Where did all these stars come from? And the answer is, PyPI automatically believes whatever I tell him, and therefore I can claim to be from anywhere, and PyPI will believe me and copy all the statistics from the projects I claim to be from into my package. This is what we call starjacking. Next, in this black box is where I will add the actual malicious code to the package. We can add anything here, but for this example, I will use a simple piece of malware, which is what we call a dynamic dropper, an interesting and hard to detect malware. What will happen is that once we publish this package, and when someone downloads and installs this package, the malicious code within this package will fetch a second stage attack from pastebin by making an HTTP request and receive additional code, which will then be injected into the running application and exfiltrate SSH keys and environment variables to a webhook. And this is a summary of everything I've done. Once I click Next, the package will be processed and uploaded. And here it is. Our package is live on Python, and you can see on the right side the 9,000 stars. This highlights the starjacking problem. You can say you are whoever you want to be, and no one is verifying if what you are saying is true or false. Now let's talk about the whys. Why is it so easy to successfully perform these open source supply chain attacks? For one thing, most maintainers do not configure two-factor authentication, making it very easy for attackers to compromise their account using just a username and a password. NPM is one package manager who did take a move in the right direction and recently took action of requiring its top 200 NPM package maintainers to set up two-factor authentication on their accounts. But now, let's assume right now everyone moves to two-factor authentication. Does this not guarantee their accounts are secure? Just this past summer, we've seen attackers advertising credential phishing services that bypass multi-factor authentication. And just this past August, we've seen the first ever organized phishing campaign ever on the popular PyPI package manager. After some joint research with Sentinel Labs, we found that the campaign was performed using two separate attack vectors, which were linked to a shared malicious domain. In the first attack vector, many phishing emails were sent to Python contributors, which led them to a fake PyPI page, from which they were tricked into providing their account credentials. The second attack vector was uploading over 100 typo squatting packages. By the way, we do know that there was some success to this campaign, since at least two popular accounts were found to be taken over and their packages poisoned with malware. Another reason, which we also talked about earlier, on why it is so easy to perform successful attacks is because anyone can lie in their package metadata, and there is no one checking what is true and what is false. Also, the ecosystem delivers auto-update features by design, meaning you may request a specific package version, but if there is a higher version to that package, then you will get that later version of that package instead of what you asked for. If you recall the UA parser attack, the attacker, understanding the way software updates, took advantage of this by uploading multiple versions of malicious packages. This ensured that whether someone performed a minor version update, a patch update, or a major version update, they will still receive the malicious code. Accounts are also willingly handed over. Developers maintain open source projects on their own free time. So sometimes life gets a little busy and they don't have the time anymore to maintain their projects. Attackers approach these maintainers and offer to maintain the projects instead. Unaware of the attacker's true intentions, the maintainers are usually more than happy to forward the control to the attackers. We also have a trust paradox. On the one hand, we have CISOs implementing zero trust security on their organization's network. Yet, on the other hand, the developers are downloading whatever code they want to integrate into their products. We also have many moving parts throughout the supply chain. Up until now, we focused on open source dependencies, but it's also important to realize that there are many other parts of the supply chain that can become compromised. Developers may accidentally install malicious plugins to their IDEs, which may, for example, alter their code, or hide things from the developers, or steal sensitive information. Developers may install malicious third-party apps on their source control without realizing it. Artifact servers might cache malicious packages even though they were removed beforehand. Developers may use malicious build server plugins without realizing it. So these are just a few examples of attack vectors throughout the supply chain from which we can become compromised. So just to quickly summarize what we just covered, there's no vetting. Accounts are taken over. We have automatic updates by design. We give too much trust. We have maintainers handing off their projects to attackers without realizing it, and we have many moving parts across the supply chain. So what can we do? There are some takeaways I would like you to take from this presentation. The first is that it is important to understand that the application security world is built around and focused around detecting and managing vulnerabilities. And I'm not saying it's not important. It is very important. However, everything I talked about in this presentation surrounds malicious code, which is not the same thing as a vulnerability. A vulnerability is a logical flaw that may or may not be relevant to you, and may be okay if it exists in your application if it is properly managed. Malicious code, on the other hand, is code that is intentionally added to cause harm and is never okay to have it in your product and cannot be managed. We also need to work together to share information with each other. Currently, whenever a malicious package is reported on, it is simply deleted and not shared with the research community so they could study it and understand the attacker's TTPs and hunt for similar attacks in other locations. We also need better standards. There is currently no universal method of classifying malicious packages. This is an example of how 4 different organizations classify the same malicious package. This is as opposed to CVEs, for example, in which there is a universal way of cataloging vulnerabilities. And finally, we are in this together. The more secure the open source ecosystem is, the more secure everyone will be. So to summarize, I talked about the differences in supply chain and software supply chain. Via the SALSA framework, we demonstrated the potential pain points. I mentioned the jungle of open source. I covered dependency-related incidents. I also demonstrated how just because something is popular does not mean it is any safer to use. I demonstrated and talked about why it is so easy to perform successful attacks on the open source ecosystem, and also give examples where we have a lot of room to improve. Remember, with great power that open source provides comes great responsibility. Whose responsibility? Our software, our responsibility. And I will conclude with, don't take code from strangers without validating it. Thank you very much.